Então hoje nós vamos falar sobre pressão. Então, elevation, change, air pressure. We're going to say about pressure and adiabatic rate. So, yeah, definitions. What is pressure? Pressure is the force exerted against an object, and the force has to be in contact with that object. For example, when I exert this force to this jar, this is pressure. And pressure has to be at a right angle or 90-degree angle. But when you do that force, you have to decompose this force into like kind of an XY diagram, and you take out the y coordinates and you get the x coordinates, and that will be your answer. Yeah, that's well. So this, when I was talking about this pressure, this is when something is confident in for example in a cube. But we're going to see about forces that are pressures that are defined as force over area, and force is measured on newtons. That is a kilo. Like when you exert a force of 1 newton, that is 1 kilo. And yeah, atmosphere is the envelope of gases surrounding the Earth or another planet. Gravity is the force that attracts a body toward the center of the other body, and the other one has to have a mass. And something that's adiabatic, that relates to a process that has no temperature exchange. Well, the abstract. When you have more height, you have less pressure. So pressure, I just told you, it was force over area. So when I do this, I have this area and force, but when I do this, I have the same force and a smaller area. So this will be stronger than this. And well, the gravity has an important role on the weight of air. Here you can see we have a syringe, and when you exert a force here we have 7 molecules of air, and when you exert a force here, the temperature is well, here we have a temperature. If we exert more force, there will be more pressure, because now we have less area and the same same amount of molecules. And so here we're going to have more heat than here, and so the pressure is force over area, and the area here is constant, but the force, I'm going to change the force as a variable. And right here, what we are doing, I have this force here, and I'm putting heat on it, and then I'm going to do pressure, and this pressure will be a force that will go upwards, and when this force becomes greater than the force that's going down, it will push the syringe up. And here I had to put heat, but when I do here from this to this, I'm not using heat. So this is an adiabatic rate, an adiabatic process. And yeah, effects. The gravity has more effect at sea level. Here we're not accounting underwater pressure, because so if I have here the center of the Earth is this jar here, And here is me. Here we have a gravity and this gravity is less than this gravity. But here is the sea level. We are not counting underwater. So that's why the greatest effect will be at sea level. When you increase altitude, the gravitational pull will be less. So when you're here, it will be less than if you were here. The molecules will spread out because there are more space and they will spread out. And for example, if you're toasting a bread and you are not focused on it and it like burns, the smoke will arise, and near the toaster there will be the higher concentration of smoke. But when it increases the altitude, it will thin, and like the air, when in higher altitudes, it will change physically and will expand. But the amount of smoke will not decrease. It will just be it's just gonna be diluted in more air, and no energy is lost at Adiabatic. And like we have a rate for every 1,000 feet, it will in ascending air every 1,000 feet it will decrease 3.5 Fahrenheit, or at every 305 meters will decrease 1.9 Celsius grade, and when you descend 1,000 feet it will increase 3.5 Fahrenheit. So that's the adiabatic rate. And adiabatics, because it does not have exchange of heat. So yeah, that is elevation, change the air pressure. And I hope you learned, and until the next class.